Okay, so here's the code for the trees mod. As you can see, there's just a main function and a block break function. Those are the only two functions. And the main function just sends a message to the player and registers the block break event to go to the block break function. So let's look at the block break function. Now, this is going to be a little advanced, but I'm going to try to do my best to explain it. The block break function obviously has the info parameter since it is an event handler function. This info parameter is going to have some information about the event, like who broke the block and what block was broken. So at the beginning of this, we're going to set up some variables. We're going to have a variable called continue flag that's initialized to true. A variable called event block, which is info's block, which is the block that's broken. And then we have three what are called hash sets. Now, hash set is a part of the Java collections, and it's basically a very efficient collection for adds, removes, contains, and size. So this is going to be perfectly fit to our algorithm because we don't need anything more than just adding, removing, checking if something is contained, or finding the size of the total collection. The way a hash set works is it organizes elements in the set by their hash value. Now, you can look up tutorials or Google what a hash value is, but just know that it is like a fingerprint. Okay, so we have three. It's called tree blocks, blocks search, and blocks to search. So the tree blocks is going to hold the blocks in the tree. Blocks searched is going to hold all the blocks that we've searched. Blocks to search is going to hold the blocks that we haven't searched yet but are going to. And then the starting point is going to be this construct here, which is in Minecraft blocks, get relative block from block in direction. This is going to give you back a block object from the event block in the direction block face up. So it's going to give you the block that's directly above the block that you just broke. That's our starting point. And what we're doing with these blocks is we're calling add on blocks to search with starting point. And this is a way we can access Java objects such as hash set and call functions on them with parameters. So with blocks to search, we're adding our starting point, and block search, we're adding our event block. And now this is the main for loop for the searching algorithm, and this is limited to 1,000 blocks. It's going to search up to 1,000 blocks, just because we don't want it to search forever and crash the game. And the way this works is it has an if statement. It says if call Java function is empty on blocks to search. This can be alternatively done with this block. So on blocks to search, call is empty, and then you just get rid of the parameters. And I actually like to use this block better. And if you right-click inline the inputs, it makes it all on one line. So let's just get rid of that. So on blocks to search, call is empty. So if there's no more blocks to search, we can break out of the loop. It means we're done searching. So, and then if it's not empty, there's still stuff left to search, we're going to set the current search block to call Java next on call Java function iterator. So what this actually looks like in JavaScript is a little bit easier to understand. What it's doing is it's this line right here. It says blocks to search dot iterator dot next, And this is iterator is a Java object. And this is going to return a Java object called an iterator, which basically lets you go through the collection one by one. And next is getting the next element of that. So this is just a it's a little bit convoluted, but it's an embedded called Java on block. So blocks to search, we're going to remove the current search block since we've just searched it, and then blocks searched, we're going to add the current search block because we've just searched it. And so here's actually the searching part, and this may look like a lot of lines, but once you understand one line of it, the rest are just variants of that one line. So it says if the current search block's type is a log or leaves, then that's part of the tree. So we're going to add it to the tree blocks hash set. And then, since it's part of the tree, we have to add everything in each direction that hasn't already been searched. So we're going to check the north, east, south, west, up, and down, and we're going to say if not block search contains the relative block in that direction, then add that block to the blocks to search. And if you watch the algorithm demonstration video, you can see how this algorithm plays out. So after this, it says else if not call Java function is transparent on current search block's type. What does this mean? It means if this algorithm runs into a block that's logs or leaves that's not transparent. If this algorithm runs into a block that's not transparent, meaning it could be a grass block, it could be bedrock, but it's not air or a torch or a ladder or vines or something like that, because those are transparent blocks. And these functions are found in the bucket API. And so if that happens, we're going to set the continue flag to false, which means that the tree runs into the ground, or it's not fully cut down, it's not fully surrounded with air. So after that entire loop, this green block was the loop, we have an if statement that says if I is less than 1,000, meaning our algorithm did not max out, meaning we have a bounded tree, and continue flag was true, we're going to set a tree block iterator we're going to call iterator on tree blocks. And like I explained before, iterator is just a way to loop over each element in a Java collection. And you don't do this with blockly blocks, because we have our handy for each item in list, because we use lists in blockly normally, but this is an example of using a Java collection. And then we have a repeat construct. We said repeat while the iterator, the tree block iterator, has next. It means if there's another value left in the tree block hash set. We're going to set a block in tree to the next item in this tree block iterator. And then we're going to use this new block. It's in Minecraft block. It's with falling block, set velocity, and then we're also using the spawn falling block. So with falling block, and then spawn falling block with type, and the type, location, and data are all going to be the same as the block in the tree. So we're basically converting the block in the tree to a falling block, and a falling block is basically a falling sand entity with the same with the same texture as the block that you're defining it as. It allows it to fall with physics. And then we're setting the velocity to some mathematical jargon. It has some x velocity and y velocity, and there's very little z velocity. It should actually be 0. And basically what this is doing is it's taking the delta between the block in the tree and the starting point, their height, and adding a constant and then timesing it by a constant. And what this is doing is it's basically saying the blocks at the top of the tree are going to move further in the x direction than the blocks at the bottom of the tree. So if you think about it, when a tree falls, the top of the tree lands very far away from the base of the tree, but near the base lands closer to the base. So that's why we have to use the delta of the height from the block in the tree to the starting point. And now for our y, the y-coordinate is actually going to be based on the delta of the block in the tree's x values, which is basically the horizontal values, not the y values, which were the height or vertical values. And it's just a constant times the delta of their horizontal distance. And this velocity provides a semi-realistic representation of a tree falling. I was tweaking these values for a little bit. You could probably find a better set of constants to better represent that, but yeah, it's also fun to set this abnormally high and just watch the tree explode. So, and then finally we're just setting a new drone, moving it to the location, and replacing that block with air, since it's now a falling block. And the server handles where a falling block falls, and it'll set it correctly at the ground. Yep, so that's the mod.